Yeah, so the bottom one, as you can see, is much further off. 53 thou, right on the money. That feels real tight. You like bitching. Howdy folks, welcome back to the second video where we're going to be straightening out the V-groove or the V-belt faces on the large pulley. This is a spindle pulley on the Jet-16 mill. And if you watch the other video, which I would encourage you to do because it has all the information on how we made this arbor or mandrel, whatever you want to call it. And I know the first video had a ton of setup, but I wanted to show you the lengths that I will go to overcomplicate things. Well, not really, but to try to figure out what that taper was without taking the actual spindle out of the lathe, the mill rather, and putting it in a lathe and then tracing it that way. We do have a problem that I noticed yesterday afternoon when I was cleaning up. We do have an interference issue. You probably may have already figured this out if you watched the other video. Yeah, it clears the ways, no problems, but I failed to consider the cross slide. And we can't go any further minus or toward the chuck with this cross slide without crashing. This is the tool that I used to do the other three pulleys. Just a tiny carbide, and I ground some relief on it, which I'm probably gonna have to do some more. This worked out really well in doing that. It gets in there, provides a nice surface finish. On this outer one here, this bigger one, the biggest one, and then the next one in, because I'm not going to be able to get at those without some sort of modification to the tooling. So that's going to be the extent of the setup in this video, and I'm still trying to figure that out. So let me work on that. We'll come right back. Well, it could work. That's probably better. Yeah, that block over there was in the way. I didn't even see it, but it worked. What I was referring to was in a setup like this, the part you're cutting off actually is part of the support for the entire workpiece until it cuts through. What I was concerned about was whether or not this clamp would want to influence it one way or the other and bind the blade up and snap it. Yeah, got to give it up to that Harbor Freight bandsaw. That thing makes pretty straight cuts. I laid this out with some Dicom to make this about 5/8, actually just under 5/8 of an inch thick, and you'll see why here in a minute. Let's see where we're at, see how we did. 590, 602, 610, about 600. So we're within 20 thou on this thing, not bad. This will be perfectly acceptable. Like I said, you'll see what I'm going to use it for here in a minute. Yeah, that's pretty close. You know, I'm not trying to go off on a tangent here, you know? Get it?
I don't get it.
Yeah. See, I had to put a new run capacitor on this a while back. How do you think I did? That sucker burned up. We'll bodge together whatever we gotta bodge together to make what we gotta make. Grizzly! We're going to start cutting on the biggest V-groove, the belt groove, but on this edge here, you see where the magnet is on the inside of that. So the furthest one up toward the chuck, which is going to be the hardest one to get at because we have this kind of an angle. Now I used my indicator, my last word indicator setup that I did with the other 3 pulleys. Had to kind of angle it a little bit and do some funky co-medina, but we got it indicated in pretty good. You got to kind of split the difference on these. But anyway, I made sure I was on center line with the center of the spindle going off the live center, and I set my stair at 120 as kind of a height gauge for that. So in case I had to move it while I'm indicating it, I can just recenter it that way, because that is important on that angle. So that's all zeroed in, ready to go. So you probably saw me do a few clips, making a few things. This is what we ended up making as a tool to get at least a couple of these, if not all of them, as far as this side of it. In other words, the angle that goes this way. And I think it's going to work pretty well. This is the standard tool that I used on all the others. There's just 2 holes in it now, M6 holes. And we got M6 bolts going into, this is I think this is 1045 steel. My neighbor down the road, not the one down there, one this way, he's got a CNC shop behind his house, and he brings me over scraps. This is one of those. We had to cut it down a little bit in the bandsaw. I don't have a mill kind of to do it right now, but we were able to get it done, and it's all clamped in nice. And so we're gonna give her a shot here. I do have to set the height of this tool. Haven't done that yet. But then we'll come back, set you up best I can. We're gonna run 200 RPM. The work piece, in this case the pulley, is tight. I tighten the nut up, so we should be good to go. Let's see what happens. You see how it's hitting irregularly like that? When you just touch off? I just wanted to point it out. We have to assume that everything else is straight. The stuff that we've done is straight. Everything measured out good. Based on that taper that we are really solidly on, and that means that that's where it's going to be on the machine too. You can see the run out on this, the way it's hitting. It's going to move it in like a thou. Not too bad. Four thou, 4.5 thou. You can see it's cleaning up right there, not there, not in here. So you can see that these pulleys are not caught right, or they're worn. And you know, when you get that kind of situation, I think that's what's causing the belts to do what they're doing. So generally what I'm doing on these, and I learned it doing the other 3, I don't really clean it up 100%. If I leave just a teeny bit back, that means I'm only skimming off the minimum amount, which is what I'll try to do on these as well. That's why I'm going a thou or 2 at a time. So anyway, we'll do a little bit more, and then we'll kind of move you around a little bit as I do other grooves, because once you see one, you know, you're pretty much groovy at that time. That's pretty good. All right, so we're going to go ahead and leave this one there. There is a small area that did not clean up. That's all right. You can see it right there now. It could be 1,000th or more, and that's it. I could probably take that off and clean it up, but it is so minuscule. I want to leave as much of the proper width of these V-grooves as much as possible. I want to leave that. I'm going to use a tool, maybe even this one, because it's, you know, it's essentially a pointed tool where I can get pretty much anywhere on any outside surface. We're going to touch up these. Well, I was thinking about touching up the inside face here, but I may not be able to get around it. I'm going to leave this one alone too. The other three pulleys rather, I did those faces, but I'm not going to worry about it on this one because this is where that nut goes up to. I'm not going to be able to do a classic reach around, I don't think, to get this. I mean, I'm going as far left or as far north to the chuck here as I can with this tool that I just made. I'm sure as hell not making another one, but we can certainly face it. The insides of these V-grooves will all be done too. At that time, I don't have to worry about angles. I can bring the compound, I can bring the quick change tool post around anywhere I want. So I can go straight in and clean those up, move it around, angle it, clean them up, do the whole thing. Now these guys here that have this little flat edge, which is simply the outside diameter of the largest particular V-groove. In this case, it's this one here. So it's got a large flat edge before this smaller diameter V-groove starts. Then you have a flat edge here before this one starts, and so forth. These are the hardest ones to get because you got to work around this flat. Now I will touch these flats up on this side as well when I get to that point. When I do the next one, for example, I'll show you the next one really quick, and we'll touch that flat up as well. And then I'm going to do all the rest off camera because, you know, once you've seen one or two, you've seen them all. So for example, we can do this outside edge right now, and I'll show you what I mean. Try putting it in gear, dummy. See how out of brown this is? I got to reset here. This is a problem with those flats. See right there? You got to make sure that the tool doesn't hit those. So you got to kind of angle this around a little bit. Because I got to be able to back out. You see how it wants to go and hit that? Like right there. All right, so what I need to do is, it's not going to change our setup at all as far as the tool height or anything. I'm just going to angle the quick change tool post just a little bit. So that should work right there. You see what I mean? Yeah, so now we can come off the edge and not hit that flat. So I'm going to go inbound with the compound and touch off again. I'm just going to use the same angle because that was pretty good. Zero the Z-axis. About 2.5 thou there. Here's 4.5 thou. The other one took about 6. Now we're a little over 5. That sounds pretty good. Yeah, so same situations before, and it's in the exact same spot too, which is weird. Right there, not exactly cleaning up, but it's close enough. So we're going to go ahead and leave that because it's almost cleaned up. You know, we keep the dimension as close as possible to what it's designed. Typically what I've been doing is I've been vacuuming in between each side that I complete. So when I do one edge and I complete it, I vacuum. We'll do a little facing on the rest of these, and maybe show you one or two of the inside ones getting done, the flats on the inside, and then this will be pretty much done. Needed a wee bit more clearance, so we ground a little bit off that front cap bolt. You know, as the saying goes, clearance is clearance. Had to make one final change though and just replace that front bolt altogether with a countersunk bolt. Note the wear pattern, that irregular pattern there. Definitely what's causing part of this problem. How we're going to do the inside flats is simply with a parting tool. Just go in there and sweep it back and forth. I found that was the best way to do it last time. I haven't done the outside edges except for this one. I'll do those later. I can just stick the other tool back in and make some adjustments to do that. I wish it would go down to like 100 and something, but it doesn't, because it might chatter a little bit, but we'll take it nice and easy and see how it goes. And you can see just how out of round that was. Yeah, it's a little chattery, but not terrible, and that's close enough. Let me just back out, move over to the next one. Good enough. All right, folks, let's see how we did. Here's the pulley all back installed. I got the nut torqued up. Been playing with it a little bit. Not entirely happy, or I wasn't entirely happy at least, with the belt because it was still doing a wobbling thing. Didn't film it, you've already seen that. So I put the old belt back on. Played with some tensions, even with the new belt, which is right down here, and the old belt. And I got it running pretty well. But the other thing I did this morning, because this is the next day, I've been playing with balancing this big pulley. And I came up with a spot that if you stacked 2 1/4-ounce weights, these are motorcycle or tire wheel weights, on top of each other at this location, it really smooths it out. Because I found a RPM, I think it was like 868 or so, that would just kind of shake this thing, but it was a harmonic. You know, it would come and go. It was just a spot that it wasn't happy with. And it doesn't smooth it out 100%, but it smooths it out about 95%. So I'm real happy with it right now. I'll show you how it runs. And this belt doesn't move as much as the other one. I think maybe this belt may have a defect in it. The way, I don't know, just the way it looks. This is the new one, the new 33. Well, this is not 33 inches. B33 means, I forgot what it is in inches. It's like a code for a certain length. This B33. Now this is a lesson to be learned here, because if you make too many changes at the same time and things either get better or they get worse, no matter what you're working on, you don't know what the change was that did it. So that's an error on my part. I should have just stuck with the original belts after I machined all the pulleys, then reevaluated it. And then if I wasn't happy with it, start switching out like one belt at a time. That's really the way I should have done it. Anyway, net sum, end result justifies the means, I think. So let's go ahead and turn it on. Right now we're at 1100 and something RPM. I am on different belt grooves, obviously. I had this one down lower and this one here, but I kind of like this range, and I got the motor down where it's got the most torque going to the first idler pulley. So flat out, she's running about 1,500 RPM. It's pretty damn smooth. And we can still go down low if we need to. That's not bad at all either. I was getting some vibration before. That's 690 something. Here's roughly 500. That's pretty good too. And it's real smooth, which it wasn't before. Now I'm not going to get it perfectly smooth on a machine like this anyway. It's a round column. There's a lot of weight hanging off of a relatively narrow support, you know, when comparatively speaking. So, you know, you're never going to get them perfect, but I got it probably as close to its perfection level it's capable of. So I'm real happy with this at this point. And I'm real happy with the way these pulleys came out, because you could see from machining this one, these were, and the others were the same, if not worse. These things were definitely out of round, worn irregularly, and had a variety of other problems. And plus, look, they look cool. They look good now. I mean, before it looked really trashy. So new belt, old belt. Gonna leave it like that for now. We'll make some changes in the future if necessary, but I don't foresee that happening. We'll pop the cover back on, turn everything off. I'll turn that off now, and then we'll be styling for the next job.